Okay, welcome to section 12.3. This is multiplying polynomials. We've worked with some multiplication of polynomials in the previous section with 12.1 and a little bit of 12.2 kind of with adding and subtracting. So what we were doing in 12.1 was we were multiplying monomials with each other. So going to like one of the examples on the book, let's just say example 1. It has 6x times 4x. We did something like this where we have to multiply the numbers with the numbers and the variables with the variables. So you get 6, 12, 18, 24 x squared for that. 6 times 4 makes 24. X times x makes x squared. One a bit more complex. Let's say we have negative 7x squared times 2x to the 5th power. Negative 7 times 2 would make negative 14. X squared times x to the 5th. Remember, we add the exponents that make x to the 7th power. We even had a couple that were like this. Let's say I have 2x to the 3rd times negative 3x squared times x to the 6th power. Again, we'd multiply all the numbers. Here there's a 1 in front of that x to the 6. That would give us negative 6 for the front numbers. Then multiply all the variables and add up the exponents. So it'd be 5 plus 6 is x to the 11th power. So we did that. All of these right here were monomials. Each one is a monomial multiplying with another monomial. Now what we're actually going to be doing is using what we had in the previous chapter, like in I believe it was chapter 2 or chapter 3, might have been chapter 1.8, where we use the distributive property. So looking at A, this is 5x times 2x squared plus 6. What we're going to do for this problem is we need to distribute this entire thing to each one of the items on the inside. I'm going to rewrite that 6. It looks pretty lopsided. 6. So we need to distribute the entire monomial to this and this individually, just like the distributive property. Remember, we've been working with the distributive property, something like this. We had to distribute the 2 to each, so that would make 2x plus 6. Well, we're doing the same exact thing, but we just have to distribute the whole entire monomial to the binomial on the inside. So this has to go to this, and then this has to go to this. So let's distribute the first thing. Let's go ahead and distribute the first set of numbers. I'm going to do it one at a time. All right. Let's distribute the 5x to the 2x squared. Remember, multiplying numbers with numbers. 5 times 2 would make 10. X times x squared would make x to the 3rd. And that would be this first one. Then we have to distribute the 5x to the 6. So 5 times 6 makes 30. And then there's no x right here to multiply, so x times whatever right here, that would be like 1, would be x. And that would be your answer. So let's look at B. A bit more complex. It just has an extra number in there. 5x squared plus 6x minus 1. Again, we have to distribute the entire monomial to each monomial. So I'm going to do 3x squared to 5x squared. That's going to give us negative 15x to the 4th. Then do the negative 3x squared to the 6x. 6 times negative 3 is going to give us negative 18. X squared times x gives us x to the 3rd. And then finally, do the negative 3x squared to the negative 1. So that's going to give us 3x squared. And that would be your answer. All we had to do was distribute it to each one. But remember, you have to distribute this whole entire monomial to each monomial on the inside. So it's just like distributive property combined with what we learned with monomials multiplying with each other. So just remember, everything here on the outside has to be distributed to everything on the inside. Everything here to everything on the inside. Let's do example 5. This one is a little different. This is going to be one of the core things you're going to be doing in the next class. You're going to be doing something called factoring, just going backwards, but you need to know how to go forward first. So example 5 tells us to multiply. And this time we have a binomial with a binomial. On the other problems, we had like 2x times x squared plus 4, something like that. We had to distribute this entire thing to both of them. Now this was a monomial to a binomial, but on this problem, we have a different one. We have a binomial. This whole entire thing has to be multiplied to this thing. So what we're going to do is this. Just like we did with this problem, where we distribute this to both of them, we're going to do that, but we're going to perform that method twice. So what I'm going to do first is we're going to take this 3x right here, and we're going to go ahead and distribute it to both things on the other side and multiply them out. So for the first two numbers, 3x times 2x would make 6x squared. Then 3x times negative 5 would make negative 15x. Now what we're going to do, since we already distributed this entire thing, this has already been distributed, we need to distribute the next number, which would be this 2. We have to distribute that 2 to everything now. So 2 times 2x makes 4x. 2 times negative 5 makes negative 10. So our goal for this was we have to take this 3x, distribute it to everything. Once that is distributed to every single thing, hypothetically if there's more numbers over here on this side, we have to distribute the 3x here, 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 here. We'd have to keep distributing it till we're done with distributing everything. Once we distribute the 3x to both of them, we then do the next number to everything. If there were more numbers over here, we'd have to distribute here, 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 keep going, and distribute to everything. And that's the multiplication process, is to take the first number, multiply it with everything. After you're done, take the next number, multiply it with everything. So then now we're in the simplification process, what we were doing in the last section. Combine like terms. There aren't any other x squared, so this would be 6x squared. We can combine this, and that makes minus 11x, and then negative 10. That would be your answer. So let's try another one that's like that. 5x minus 2 times 2x plus 3. Again, we have to distribute the first term to both of them. That would give us 10x squared for the first one plus 15x for the next one. After the first one distributed to everything, distribute the second one to everything. That gives us negative 4x minus 6. The multiplication process is done. Now go ahead and simplify. We can only combine these two numbers. So it'd be plus 11x minus 6. All right. So let's look at the next problem. Example 6. This one has 2x minus y squared. Now, this one's a little different. It's going to be the same process, but let's think about like what this means, the 2x minus y squared. Well, think about what x times x makes. X times x makes x squared, right? So whenever we have one number times the other number, it's the same number. That just makes that base number squared. So again, if I had like x to the third power, that would be x times x times x if I broke it down. Here, for this problem, if I have 2x minus y squared, it'd be that entire quantity broken down. So even if I had something like xy squared like this, that would make it into xy times xy. It's basically the entire inside multiplied by itself times however many is mentioned here. So for 2x minus y squared, 2x minus y squared, that simplifies, or we have to expand it to 2x minus y times 2x minus y. Then we can go ahead and do that distributing process. So we can take this, distribute it there, and then take the next one, distribute it here, and here. So 2x times 2x makes 4x squared minus 2xy. Then the second one distributed makes minus 2xy plus y squared. So it looks a little funny because we had to distribute the same thing. So now the next one, we go ahead and combine the like terms. That's going to give us 4x squared minus 4xy plus y squared. And that would be our answer. Let's look at example 7. This one is a little different. Example 7. It says to multiply, so we're going to go ahead and multiply everything. It wants us to do t plus 2 times 3t squared minus 4t plus 2. Now, this one has a bit more involved, but remember what I just told you in the last problem. We need to take this first one right here and distribute it to every single thing on the other side. So distribute the first number, or the first variable to everything. That's going to give us 3t to the third power for the first one, minus 4t to the second power for the second one, plus 2t for the third one. So this represents our first one, second one, our third one for the 3 distribution processes. Now go ahead and distribute the next one, this to this to this, as we distributed everything. For the first one, it makes plus 6t squared minus 8t plus 4. So this would be the first distribution, the second distribution, the third distribution. So if you have any more numbers than 2 binomials, if a binomial and a trinomial like this, you have to distribute a bunch of different numbers together. It makes a longer polynomial that we have to simplify. So now let's go ahead and see what we can combine. We don't have any other t to the third powers, so I can go ahead and write down 3t to the third power. Since I have a lot more variables here, you can cross them out if you want to. It really doesn't matter what you do. I'm going to move to the next one. I have a t squared and a t squared here. I can combine those. That makes plus 2t squared. Then I have a 2t and a negative 8t. That's going to make negative 6t. And then I just have a 4 by itself. And there's your answer. So the more numbers you have multiplying, the more complicated it can get. There's a lot more going on. Let's try something different. I'm going to make one up. Okay, what if I have something like this? Let's say I have 2x squared plus x minus 4 times x squared minus 4x plus 3. This is a big old trinomial with a trinomial. This was going to be a big problem, so I'm going to kind of scoot it over here. We're going to have to distribute, remember we have to distribute the first term to everything on the right side, then the second term to everything on the right side. In this case, we have a first term that has to be distributed to everything on the right side. Distribute it to everything right there. So for those three numbers, it becomes 2x to the fourth for the first one, minus 8x squared, plus 6x squared. So that's for the first one. Now we have to distribute the second one to everything on the right side. So x times x squared makes x to the third. X times negative 4x squared. X times 3 makes 3x. And the last one, we have to distribute the last term to everything on the right side. So this makes negative 4x squared, going to kind of squeeze it in here, plus 16x minus 12. As you can see, there's a lot of different numbers that come out right here because we had to do a trinomial times a trinomial. Makes it more complicated and it makes it a bit longer. So let's go ahead and start combining like terms. And this one I'm probably going to cross out stuff after I'm done with it, make it easier. There aren't any 2x to the fourths, so that one's gone. Let's look for the next one, x squared. Oh, here's a x squared right here. And then we have an x squared right here and right here. So we have 1, 2, 3, 4 numbers we can combine. Negative 8 plus 6 is negative 2x squared. So I'm going to add all of these together. Negative 8 plus 6, negative 2, minus 4 more is negative 6, minus 4 more is negative 10x squared. So all of these are now gone. Let's see if there's any other x to the thirds. I don't see any other x to the thirds, so we're just going to write down plus x to the third. That's gone. Now combine 3x and 16x. That's going to make plus 19x and then minus 12. That'd be a final answer. We can rearrange it to have it in descending degree order, meaning I want to probably put this right after that 2x to the fourth, so I'm going to rearrange it because of the commutative property. 2x to the fourth plus x to the third minus 10x squared plus 19x minus 12. Essentially swapped this one and this one so that they're in order. And there's your answer. So having a lot more numbers involved makes it a bit more complicated. You might have something like this in your next class where you do a trinomial times a trinomial. But this whole multiplying idea is always going to be the first number to everything, and then the second number to everything, and the third number to everything. This is the easiest way to learn multiplication of polynomials. You'll learn different methods called the FOIL method. You don't really need to know how to do it necessarily by the FOIL method because what I'm showing you right now is essentially the FOIL method. There's just no acronym. So the idea is I always want you to remember no matter how many numbers that we have right here, always take the first to everything, then the second to everything. If I have even more numbers, remember, it's always the first one to everything, then the second one to everything. So this example is an extreme example. We had to do each one to 3 of them. That's a multiplication process. Let's look at example 8. This one's interesting. It wants us to multiply. And this says 3a plus b to the third power. Oops. So remember, anything to the third power means it's that base times itself 3 times. As I gave the example earlier, x times x would make x to the third. But remember, you can go backwards. If you have x to the third, that makes x times x times x. You take the base and multiply it by itself 3 times. So for 3a plus b to the third power, we can expand it to 3a plus b, 3a plus b, 3a plus b. And with this kind of multiplication problem, what we're going to want to do is take it step by step. We're going to distribute this to here, and then this to here to here. We're going to ignore this one. We're just going to leave it off to the side for right now. So we're going to go ahead and multiply these first. So if we multiply the first one, for the purple, 3a times 3a makes 9a squared. 3a times b makes 3ab. For the blue, b times 3a makes 3ab. And b times b makes b squared. Put that in parentheses. All of this just became this right here. And don't forget to write this one down, 3a plus b. We copied over because we haven't multiplied it yet. Remember, the essence of simplifying all these algebraic expressions and problems that we've been doing is whatever we don't touch, just go ahead and rewrite. So 3a plus b we rewrote. Before I even multiply those, let's go ahead and simplify this. I can put 3ab and 3ab together. That makes 9a squared plus 6ab plus b squared. Now that we've multiplied all of this and it became all of this right here, we can go ahead and start multiplying the next round. So we need to take the 9a squared and we're going to multiply it with two things over there. So we're going to have to distribute the 9a squared to here and to here. Then we'll have to do the 6ab to here and to here. And we'll have to do the b squared to here and to here. So let's look at the red first. 9a squared times 3a makes 27a to the third. 9a squared times b makes 9a squared b. It gets a little challenging now, because we're looking at all the different numbers. We have to pay attention to everything, every little detail. We're done with this one. We've already distributed that. Now we need to distribute this one to both of them. 6ab to 3a makes 18a squared b. 6ab to b makes 6ab squared. This one is done. We move to this one now. B squared times 3a makes 3ab squared. And then b squared times b makes b to the third power. Have another long problem, and now we got to go ahead and simplify everything. This one right here, there aren't any other a cubes, so 27a to the third power. A squared and b. A squared b, a squared b. Those two can combine. That makes 27a squared b. Next one, ab squared, ab squared. That makes 9ab squared. And then b to the third power is right there. That's an extreme example. Yes, you will have some of these in your next class. Might have a couple. This class, not really. I'm not necessarily going to test you over that type of problem all the time. There might be one problem like that, but not a lot of problems like that at all. Just one problem. All the rest of the problems are going to be a little easier in respect to like the first few problems that we were doing. So multiplying all these polynomials is crucial because in the next class you're going to be doing something called factoring. You'll be going backwards. Essentially, if you have x squared plus 4x plus 4, you're going to be going backwards and you're going to have to figure out how to find this from this. So it's important to know the other way around. You got to know how to multiply forward. You got to multiply how to do, or you got to know how to multiply this. Just like this. In order to do backwards in the next class. Okay, this is section 12.3. Going to go to 12.4. It's a short section. I don't delve in it too much as it deals with something called special products.